The big change in the move from C to C++ was the addition of object orientation, and this comes in the form of adding classes. And it turns out that in C++, classes and structs are very close relatives of one another. The difference is just visibility. So to help illustrate this, I want to have us write a simple class, at least begin it. It'll probably take several videos to do this, and show the primary syntactic elements that are part of a class. So, the class we're going to write is for complex numbers, and I'm going to create two files here, both a header file and a CPP file. In the header file, as we discussed previously, I want to put a guard around here, so that it can only be included once. And then I'm going to define the class. So a class definition starts with the keyword class, followed by the name of the class, and then curly braces and a semicolon. We'll add a little bit more to this when we get to the point of dealing with inheritance. The semicolon winds up being significant. It's a very easy thing to forget. If you leave it off, you will get interesting error messages. So try to remember the semicolons at the end of classes and structs. Just like in Scala or other programming languages that you're used to that have object orientation, you can specify visibility. In C++, the visibility is specified in blocks. Now, in a class, by default, the visibility is private. So if I just put something in here, double real double imag for the imaginary part, both of those elements are private, so outside code cannot access them. We can be explicit about this by putting in a tag that says this is private, and then when I want things to be public, I would put in a tag for public. Everything from one tag to the next has the visibility of what came before it. Literally the only difference in C++ between a class and a struct is that in a class the default is private, so if you don't put any visibility, everything will be private and the class will be pretty useless. Whereas in a struct, by default, everything is public. And so you would have too much visibility for all of your data, but it's fitting with how things worked in the C programming language. Okay. This class happens to be mutable. At least right now, most likely because I have these two fields in here. I didn't declare them consts, so they can wind up changing. We'll talk more about the nature of const and maybe come back and talk about editing our complex class. I also want to put in methods and constructors in here. So in order to be able to use this class, one of the first things I need to be able to do is a constructor. In Scala, you almost never defined a constructor for things because the arguments that you passed into the class were the constructor for it. In C++, Java, and most other older object-oriented languages, you actually have to specifically define your constructors. In C++ and Java, the constructor has the same name as the class, and then you give it the arguments that it's supposed to take. I'm actually going to write two constructors here. Now, I've put semicolons there saying that this is just a declaration of it. And at that point, I need to jump over here to my CPP file, my source file, and I'm going to define these. And actually, let's go ahead and put in our include of complex.h. This is something you'll see a lot. The source file includes the header file. And then I can put these methods in here. Or in this case, the methods are my constructors. This particular one is fairly simple. Real equals R, imaginary equals I. The other one is even easier. It lacks the imaginary part, and so that would be set to 0.0. Okay. Things about this. First off, I've done something I shouldn't do. We'll come back and correct that in just a second. The way in which this is split up. So we could have put the definitions of these functions up here in the class complex. When you define something inside of the class, it tells C++ that you mean it to be inlined. So you should only do that for very short functions. These are short enough, we could probably get away from it, or get away with it, and stylistically no one would complain. However, I'm kind of going overboard on putting everything in the source file to illustrate to you that we do have a separation. When we talk about templating, you'll see that for templated classes, all the code has to go into the header files. Generally, even then though, it'll be after the class instead of inside of the class. You should put very few things inside of the class itself as far as the implementations go. It should just be the definitions of things. So what's the other thing that's wrong here? Well, it turns out that while this syntax looks natural to you for defining these variables, this is not the way we should do it in C++. Instead, we should use what's called an initializer list. And the syntax for that is like so. And then the body of the function in this case winds up being empty because we didn't need to do anything. Everything that we initialized, we were able to do with the initializer list. Why use initializer lists? Well, in the case of the type double, it really doesn't matter much because doubles are not initialized to anything by default. But if you don't use an initializer list, what happens is when C++ actually gets into the body, by the time that it gets into these curly braces, it's already done a default initialization of things. So for example, if these had been strings instead of doubles, if we didn't use an initializer list, they would have been set up as empty strings, which potentially does memory allocation. For the case of a string, it won't actually have to allocate anything for the empty list, but it will do work. And then we'd get into the function here and we'd wind up doing more work giving it its initial value. The initializer list prevents that, and there are also some things, for example, if we had references in here, you absolutely must use an initializer list. It's good to get into the habit of all initialization of your fields should be done with the initializer list as much as possible. There will be some situations where you can't, and they will go in the body of the constructor, but most of the time you should. Note this syntax only works for constructors. The last thing to note here, you might wonder about this because I'm just writing this constructor, complex takes a double. And what's going on here? Well, if I just wrote complex takes a double, C++ would think that I'm just writing a function and that I somehow forgot the return type on that function. By putting the scoping operator in the class, we're saying that we are writing this, which is a member of this class, and that's essential for everything that we write which is associated with the class.